Hello everyone, in this video we are going to see selection sort. In this algorithm we find the minimum or maximum element in the array and place it in correct position. This is done repeatedly until we get our sorted array. Now let us take an example. Assume this is an array. First of all we need to find the minimum element in the array. As you can see, 3 is the minimum element of the array, so we will swap this element with the first element of the array so that 3 comes in the right position. Then we find next smallest element in the remaining array, leaving the first element of the array. As we can see, 13 is the minimum element of the array. So now we will swap this element with the second element of the array so that this comes in the correct position. Then we find minimum in the remaining array, leaving the first two elements, and this is done n-1 times so that we can get our sorted array. You can see the remaining transition for selection sort. Now let us program selection sort. This function is useless, so we remove it. This is the main function in which we are given an array and we are given the size of the array, which is n. So for selection sort, we need to run a for loop from I equals 0 to I less than n-1, and we will increment I. Inside this for loop, we will find minimum element of the array. Let us assume a variable mini which will store the index of the minimum element of the array. Now we will write a nested for loop which will run from I and will go till n, and we will increment j. Then inside this for loop we need to find the minimum element in the remaining array. So we will write the condition if element at index mini, if this is more than element at j, then we will update mini with j. Outside this for loop, we will get the index of our minimum element. So we will now swap the element at index mini with element at index I. Swap is a inbuilt function in C++ which will swap the element at index I and index mini. So this is the function for selection sort. We will compile and see is it working fine. So now let us discuss the time and space complexity for this solution. As you can see, we are using two for loop, one inside another. So the time complexity of this solution goes to n square. Coming to space complexity, as we are not using any extra space in this solution, so that space complexity remains big of 1.